Hi, welcome to another video. So Google has just introduced Gemma-4 12B, and I think this is one of the more interesting local model releases from Google in a while. And the reason is simple. This is not just another small Gemma model that is only good on a benchmark chart. This one is specifically designed to run agentic, multimodal workflows directly on laptops, and Google is also releasing a proper local ecosystem around it with AI Edge Gallery on macOS, LiteRT-LM serving, Ollama support, LM Studio, Hugging Face, Kaggle, and support for agent tools like Hermes, OpenCode, OpenClaw, Aider, Continue, and so on. So let's talk about what Gemma-4 12B actually is, why the architecture is interesting, and then I will show you the practical setup paths. Now, first of all, Gemma-4 12B was announced on June 3, 2026. Google describes it as a unified, encoder-free multimodal model. That sounds like normal AI marketing language, but the actual idea is pretty interesting. Most multimodal models use separate encoders for different inputs. So, if you give them an image, the image goes through a vision encoder. If you give them audio, the audio goes through an audio encoder. Then the outputs from those encoders are passed into the language model. That works, obviously, but it also adds latency, memory usage, and extra components. With Gemma-4 12B, Google says they removed that separation. Vision and audio inputs flow much more directly into the LLM backbone. For vision, they replaced the larger vision encoder with a lightweight embedding module. For audio, they removed the separate audio encoder and project the raw audio signal into the same kind of space as text tokens. So, in simple terms, instead of having a big model plus a separate vision model plus a separate audio model, this is more like one unified model that handles text, images, and audio in a cleaner way. And that matters because this model is meant to run locally. Google says it can run on consumer laptops with 16 gigabytes of VRAM or unified memory. That is the important number here. Of course, 16 gigabytes does not mean every laptop will run it beautifully with a massive context window, tons of attachments, and everything maxed out. But it does mean that this is not one of those fake local model releases where the model is technically open, but practically you need a data center to use it. If you have a decent Apple Silicon Mac, a gaming laptop with enough VRAM, or a desktop GPU with enough memory, this should be in the realistic zone, and that is why I think the 12B size is important. Gemma-4 already had smaller edge models like E2B and E4B, and bigger models like the 26B mixture of experts and the 31B dense model. But 12B sits in a much more practical middle. It should be stronger than the tiny edge models, but still much easier to run than the large models. Google also says the performance gets close to the larger 26B MOE model on standard benchmarks, while using less than half the total memory footprint. They also ship it with multi-token prediction drafters, which are meant to reduce latency. That is one of those details that sounds small, but for local models it matters a lot. If a model is technically capable, but the response speed feels annoying, people will not use it daily. Now, as always, take benchmark claims with a grain of salt. If you have watched my older Gemma videos, you know I do not blindly trust Gemma benchmarks anymore. Some previous Gemma models looked way better on charts than they felt in actual usage, so I would not say this is amazing just because Google has a graph. But the architecture and the local workflow story here are genuinely interesting. And the model is released under Apache 2.0, which is also good. That makes it much more useful for developers who actually want to build things without worrying about weird licensing. Now, the other big thing is that Google is not just saying, here are weights, good luck. They also say Gemma-4 models have crossed 150 million downloads, which shows that developers are actually using this family and not just watching launch demos. They are giving several ways to try it. You can use LM Studio, Ollama, Google AI Edge Gallery, Google AI Edge Eloquent, LiteRT-LM, Hugging Face Transformers, llama.cpp, MLX, Sklang, VLL, Unsloth, and Google Cloud. So, there are basically three practical paths I think most people should care about. The first one is the easy app path. The second one is the local server path. And the third one is the agent workflow path with tools like Hermes. Let's start with the app path because this is probably the easiest way to show it on screen. I have the Google AI Edge Gallery page open here, and the first thing you see is the line, Discover Private Offline Models on Device. Under that, you have download buttons for Android, iOS, and macOS. The macOS part is the new interesting thing for this video because Google AI Edge Gallery is now available as a Mac app. This is basically Google's local AI showcase app. It is not just a chat app in the cloud. The whole point is to explore on-device models on mobile and laptop devices. The page says it is for private offline models, and it lets you experiment with local AI features for text, vision, audio, and multimodal workflows. It also mentions settings, benchmarking, and importing your own models. So, if you want the easiest visual demo, you download Google AI Edge Gallery for macOS, install it, choose the model, download it, and then run it locally. Obviously, the model file is going to be large, so do not do this on a machine with no storage or very little memory and then act surprised. But the user experience is much more approachable than manually pulling weights, converting formats, and writing inference code. The more interesting part is the coding demo that Google showed for the Mac app. Google says AI Edge Gallery on macOS can use Gemma-4 12B to generate and execute scripts locally. In one example, they gave it 2 text files with name data and asked it to use a Python program to render a chart comparing the top 10 girl names born in 2024 versus 2025. The model generated Python code, executed it locally, and turned the data into a chart. That is actually a really good demo for a local model, because this is not just write me a poem. This is closer to a local agent loop. You give it files, it writes code, it runs the code, and it produces an output. Google's developer guide also says the Mac app has a secure sandboxed Python execution loop for writing, executing, and plotting scientific charts inside the chat bubble. That is exactly the kind of thing I want from local AI apps, not just chat. Actual useful local workflows. Now, is this going to replace Claude Code or Gemini Code Assist, or a top cloud coding model for huge code bases? Probably not. At least I would not assume that until we test it properly. But for privacy-sensitive local data analysis, small scripts, charts, quick visual insights, offline coding experiments, and local document workflows, this is very cool, and the fact that it runs on device means you are not paying token bills every time you ask it to process your files. That is a big deal for students and for people who just like local tools. Now, the second setup path is LiteRT-LM. This is the one I think developers should care about the most, if they want to connect Gemma-4 12B to other tools. Google's LiteRT-LM CLI can run .LiteRT-LM models on Linux, macOS, Windows, or Raspberry Pi. It also has a serve command, which starts a local HTTP server that is compatible with the OpenAI API. That is extremely important because once you have an OpenAI-compatible local endpoint, a lot of tools can talk to it. Hermes can talk to it. OpenCode can talk to it. OpenClaw can talk to it. Continue, Aider, custom scripts, and other tools can also talk to it. If you already use Hermes, you can point Hermes at that local endpoint as a custom OpenAI-compatible provider. So, in Hermes, you would set the base URL to http localhost:9379/v1. You would set the API key to a dummy value if Hermes requires one, because local servers often do not care about the key. And you would set the model to Gemma-4 12B, GPU. Now Hermes can use Gemma-4 12B locally. That means your agent workflow, your skills, your tools, and your local tasks can run through a model on your own machine. This is the setup I find the most exciting, because AI Edge Gallery is great for trying the model in an app. But LiteRT-LM plus Hermes is how you turn it into a workflow. You can ask Hermes to work on a small repo, summarize files, generate scripts, process local data, or do agentic tasks, and the model request can stay on your machine. That does not mean it will be perfect. Local models are still local models. Some are worse at tool calling, some are worse at long horizon tasks, and some will randomly fail in ways that strong cloud models do not. But for a 12B local model, if the instruction following and tool behavior are decent, this becomes a very compelling low-cost setup. And because Hermes is already good at provider flexibility, you do not have to marry this model forever. You can use Gemma-4 12B locally for normal or privacy-sensitive tasks, then switch to a stronger cloud model when something is too hard. That is the best version of local AI in my opinion. Use local where it makes sense. Use cloud when you actually need cloud. Do not burn expensive tokens for every tiny thing. Now, the third setup path is Ollama. This is probably the easiest one if you already live in the Ollama ecosystem. The basic command is Ollama run Gemma-4, and on the Ollama Gemma-4 page, they even list application launch commands. For Hermes agent, the command shown is Ollama launch Hermes -- model Gemma-4. That is very nice, because it makes the Hermes path extremely simple. Install Ollama, run Gemma-4, and launch Hermes with that model. You can also launch other tools the same way, like OpenClaw, OpenCode, Codex, or Claude Code, depending on what you use. One small caveat though. Check the tags before assuming exactly which model and capability you are using. On the current Ollama page, I can see the new Gemma-4 12B-MLX tag, and that one is optimized for MLX and listed as text input. So if you specifically want the Google AI Edge workflow that Google is showing for Gemma-4 12B, I would use the AI Edge path or carefully check the exact Ollama tag before assuming the same input support. But if you just want the simplest agent setup, Ollama plus Hermes is probably the least annoying way to start. Now, how would I actually recommend using this? If you just want to play with it, download AI Edge Gallery for macOS and try the local app. That gives you the easiest experience and a good feel for what Google is building. If you want to connect Gemma-4 12B to tools, use LiteRT-LM serve. That gives you the OpenAI-compatible endpoint on localhost :9379/v1. Then connect Hermes, OpenCode, OpenClaw, Continue, Aider, or whatever else you use. And if you are already an Ollama user, try the Ollama route because it is very straightforward. For Hermes specifically, I would probably try both the Ollama and LiteRT-LM setup. Ollama is easier. LiteRT-LM is more directly tied to Google's optimized local stack, and AI Edge Gallery is the best visual app demo. So each one has a different purpose. Now my overall take is this. Gemma-4 12B is interesting because it is not trying to be the biggest model. It is trying to be the practical local model. It has a real mid-size parameter count. It has a unified multimodal architecture. It supports audio input, which is new for a medium-sized Gemma model. It can run on 16 gigabytes class machines. It has Apache 2.0 licensing. It has AI Edge Gallery for normal users. It has LiteRT-LM for developers. And it can plug into agent tools through local OpenAI-compatible serving. That is a very strong story. Now, the real question is whether it actually feels good in daily use. Can it follow instructions? Can it use tools reliably? Can it write code that works? Can it handle multimodal tasks without falling apart? And can it do all of that at a speed that feels usable on a normal laptop? Those are the questions that matter. Because we have seen many models that look amazing in launch posts and then feel very mid when you actually use them. But I like the direction here. Google is making a local model that is not only for chat, but for agentic workflows on normal hardware. And they are giving people app, CLI, server, and agent integration paths. That is exactly what local AI needs, not just weights, a real ecosystem. So overall, this is pretty cool. If Gemma-4 12B actually performs well in real coding and agent tests, then this could become one of the more useful local models for people who want privacy, offline access, and lower costs. And if it does not, then at least the AI Edge stack itself is still moving in a very good direction. Overall, it's pretty cool. Anyway, let me know your thoughts in the comments. If you liked this video, consider donating through the Super Thanks option or becoming a member by clicking the Join button. Also, give this video a thumbs up and subscribe to my channel. I'll see you in the next one. Until then, bye.